Let me solve a problem to find the Fourier series of an odd function. Example: find the Fourier series of x in interval from minus pi to plus pi. X is my function f of x. Solution: well, this is my formula Fourier series. My given function is x, which is f of x. Step 1. To check that whether the function is odd or even. So the very first thing that I'm gonna do here is to check that whether the function x is odd function or even function. It's very easy. Just multiply the variable x by minus, which equals to minus x. It is not my original function because my original function f of x equals to plus x, not minus x. Therefore x is odd function. Don't forget, we have already talked about odd functions and even function. Just remember that. Now I'm going to find the values of the coefficients a sub naught, a sub n, and b sub n. Step 2. Where a sub naught equals to 1 over 2 pi times integral of x dx. Remember, my function f of x equals to x. It is an odd function. So according to the Fourier series, if the function is odd function, it equals to 0. Therefore my a sub naught equals to 0 here. Now a sub n, which equals to 1 over pi times integral of x times cos nx dx. The given function f of x equals to x, which is odd function. Cos nx is even function. So odd function times even function equals to odd function, which means that this whole thing is odd. Therefore it equals to 0. Because according to the Fourier series, if the function is odd function, it equals to 0. Now I'm going to take b sub n, which equals to 1 over pi times integral of x times sin nx dx, which equals to 1 over x into 2 times integral of x times sin nx dx, with a range from 0 to pi. I just changed the limits from 0 to plus pi and multiplied it by 2. The given function f of x equals to x, which is odd function. Sin nx is also odd function. So odd function times odd function equals to even, which means that this whole thing is even. Therefore I can find the value of b sub n. If the function is even, you can calculate further, but if the function is odd, it automatically equals to 0. So here my b sub n is even function. Therefore I'm going to calculate for 8. So it is the product of two functions. One is an algebraic function and the other is trigonometric function. To solve it further, I'm going to apply the integration by parts technique. This is the common formula that we use for the integration by parts. But since I have one algebraic function here, which is x, therefore I'm going to apply another technique here. At the left put differentiation and at the right put integration. Write the algebraic term under differentiation panel and trigonometric function under integration panel. Derivative of x is 1. Integration of sin nx is minus cos nx over n. Derivative of 1 is 0. Integration of minus cos nx over n equals to minus sin nx over n square. So I'm going to stop the process here because at the left side I have 0 at the end for differentiation. So the moment when you get 0 for the differentiation panel at the end, you have to stop the process. For this technique, you must have at least one algebraic term. If you don't have pure algebraic term, you can't use this technique. Right now I have one pure algebraic term, which is x. Therefore I'm going to use this technique. Now don't forget, we have already done this technique if you reflect back to the section which is integration by parts. I have done several problems using this technique. Just go and check integration by parts section. I have minus and then plus and then minus. Take cross multiplication here. Take the cross product between these two terms, which equals to minus x times cos nx over n, and product between these two terms, which equals to plus sin nx over n square, because minus times minus equals to plus. This is my output here. Just put it here. Now expand the limits where these two terms are 0. Cos n0 equals to 1. But it's the product of 0, so this term is also 0. So at the end I left only with 2 over pi into minus pi times cos n pi over n, which equals to minus 2 over n into cos n pi, where cos n pi equals to minus 1 to the n. The value of cos n pi depends on the value of n. So this is my final value for b sub n, which equals to minus 2 over n into minus 1 to the n. Just substitute this value in the value of a sub naught and a sub n, which are 0, in the formula here. The value of a sub naught and a sub n are 0. And the value of b sub n is 2 over n times minus 1 to the n times sine nx. So at the end I have only the value for b sub n, because a sub naught is 0 and a sub n is also 0. Now I'm gonna substitute some values for n. If I put the value of n equals to 1, this term will be 2 sine x. And if I put the value of n equals to 2, this term will be sine 2x. If I put the value of n equals to 3, this term will be 2 over 3 times sine 3x. But if I put the value of n equals to 4, this term will be 1 over 2 times sine 4x, and so on. This is my final Fourier series for the function x, which is an odd function.